So when we're working on solving by taking the square root again, there's no b term. So I want the squared term on one side, the constant on the other. So in this first one, 9n squared equals 342. The first step would be to divide both sides by 9 to get that n squared by itself. So what is 342 divided by 9? I believe it's 38, correct? So I get n squared equals 38. So I have the squared term on one side, the constant on the other. At this point, I can take the square root of both sides. So n is going to equal positive or negative square root 38. Is the square root of 38 a perfect square? Do I get a whole number if I put in the square root of 38 into my calculator? Nope. So it would depend. If they asked for it in decimal form, you would convert that to a decimal, or we could just say our solution set. And I know that you saw on the quiz on Thursday, some of the answers were in solution sets instead of saying solution equals. The solution set is just a bracket, and we would do positive radical 38 and negative radical 38 bracket. That would be the same thing as saying the solution equals. We're just putting it into what's called a solution set. It's not about me taking points off because I would accept it whether it says solution equals, brackets, whatnot as far as the homework goes, but I'm kind of starting to prepare you for the final exam, and you have to be able to look at what format do they put the answer in. Do they put it in? Sometimes they'll put it as x equals positive radical 38, x equals negative radical 38. Sometimes they'll put it in a solution set like this. So it's not about what I'll accept, it's about how the final exam is going to be giving you the answer choices and that you are prepared for those choices. All right, number 2, 25m squared minus 9 equals 72. So I need to get this constant off to the other side. So I'm going to add 9 to both sides. So I get 25m squared equals 81. But I need to get that 25. I'm going to divide by the 25. And it's okay that 81 doesn't divide by 25. It's okay to have a fraction. So we have m squared equals 81 divided by 25. Now I have the squared term on one side, the constant on the other. So now I can take the square root of both sides. So m equals positive or negative square root of 81 over 25. Now, if you were to put that in your calculator, it's going to give you a decimal back possibly, or it will, depending on which calculator you have, it will give you the fraction. But when you are taking the square root of fractions, you take the square root of the numerator and the square root of the denominator separately. So this is the same thing as saying m equals plus or minus square root of 81 divided by the square root of 25. What is the square root of 81? 9 and the square root of 25. So our m is going to equal positive or negative 9/5, and we're going to leave our solution like that. 9 over 5, comma, negative 9 over 5. Now, if you converted it to a decimal, because I know the question is coming, would I accept that as a homework answer? Absolutely. But again, I'm trying to prep you for the final exam as well, where they would leave an answer like this as an improper fraction. They wouldn't turn it to a mixed number. They wouldn't turn it to a decimal. they would just simplify it and leave it as an improper fraction. So I want you to be familiar that that's the way the answer could present itself on the final exam so that you're aware of that. Then the third one, 7x squared minus 1 equals 6. So again, I'm going to add 1 to both sides. So 7x squared equals 7. Divide both sides by 7 and get x squared equals 1. Now I can take the square root of both sides. So x equals positive or negative square root of 1. Well, 1 happens to be a perfect square. So x equals positive or negative 1. So our solution set would be 1 comma negative 1. So again, solving by taking the square root falls under the bigger umbrella of solving by factoring, but it's a case where we don't have a b term, where we only have ax squared plus c. And instead of having to go through the whole x method, we can use the solving by taking the square root as a way to simplify that. All right, when I made the packet, I'm not always sure of how many days, situations that are going to happen. So I did add an extra lesson in here that I was hoping we would get to. It didn't happen that way. So there's a lesson in here called Simplifying Radicals, I think is the name of it. We're going to end up crossing that activity out because we do not have time for it. All right, so again, simplifying square roots, we're going to cross that out. We're not going to have time. We're getting a little low on time, so we're going to cross out that activity. Which then is going to take us to page 23, where we're going to start working on the quadratic formula. Now, up until this part, I have been telling you that the methods we've been learning, solving by graphing, solving by factoring, which again includes solving by taking the square root, solving by completing the square. All of those methods only work in certain situations. They do not work every time. I've told you I only use solving by graphing if they make me and give me a graph. Solving by taking the square root, only if I look at it and I can see it's nice and pretty and easy to do. Solving by factoring, the same thing. Really, when I'm solving by factoring, I'm looking for an a value of 1 and numbers that are pretty small that I can do easily. Solving by completing the square, I only use that if the b term is an even number, and really if the a value is 1. Otherwise, it gets a lot trickier. So with all that being said, I've told you times only specific instances that those work. The quadratic formula that we're going to start learning today, this is the one way that works all of the time. So when I'm looking at a quadratic equation, and if I don't feel the other 3 or 4 methods are really good or going to be any faster, I default back to the quadratic formula because this is the one method that can be used in any situation to solve any quadratic. Now, part of the quadratic formula is something called the discriminant. The discriminant is actually, you're going to see in a little bit, a part of the formula. And the discriminant is a formula that tells us the number and type of solutions or roots sorry, the screen is jumping around on me. Solutions or roots a quadratic function has. And remember, the solutions or roots are telling us how many times does our function cross the x-axis, or as we're going to learn, does it cross the x-axis at all? Now, the formula is b squared minus 4ac. But before you can use that, your function does have to be in standard form. We do have to have ax squared plus bx plus c equals 0. Very important for anything quadratic formula. One side of your equation must be equal to 0. We're going to add that as a little asterisk here. One side of the equation must be equal to 0 before any work can be done. I can't determine what the value of A, B, and C are if I don't have one side equal to 0 yet. That is a requirement. And then once I do, the A will substitute in where I see A, the B substitutes in for the B, and the C substitutes in for the C. And I work out that math. And then this chart tells me if that value is greater than 0, that means I have two real roots or solutions. And what that tells me is my function crosses the x-axis twice. That's what it means to have two real roots. That means my function is crossing the x-axis twice. If I do that, my discriminant is less than 0, or in other words, I come up with a negative value, that means I have two imaginary roots or solutions. Or in other words, no real solutions. Which is telling me my function doesn't cross the x-axis. And if my discriminant is equal to 0, that means I have one real or double root solution. And this is telling me my vertex is on the x-axis. So I need to understand what each of those values are telling me, besides telling me if I have one real solution, two real solutions, or no real solutions. What does that mean in context? Two real solutions means my function crosses the x-axis twice. One real solution means that my vertex is on the x-axis, and no real solutions or two imaginary solutions means that my function does not cross the x-axis. So it's important for me to understand what that is telling me. But again, we have to have one side equal to 0 before we can put that into work. So here, the first set of example, find the discriminant of each quadratic equation, then state the number and types of solutions. So here we have p squared minus 2p plus 1 equals 0. We already have that one side equal to 0, so we don't have to do anything there. So we have A, B, and C. So in this case, A is 1, B is -2, and C is 1. So I'm going to substitute into my discriminant. Again, my discriminant, D equals B squared minus 4AC. So I need to substitute into that to find out what is the value of my discriminant, so I know, again, what type and how many solutions I have. So D equals, now my B is -2, so I have to do parenthesis -2 squared minus 4 times 1 times 1, because A and C are both 1. So when I substitute them in, putting in 1s. So -2 squared would equal +4. -4 times 1 would be -4. So D equals 4 minus 4. D equals 0. So by my chart, if my discriminant equals 0, how many solutions and what type of solution do I have? I have D equals 0, so I have one real solution. And again, what this is telling me is my vertex is on the x-axis when I get D equals 0. All right, number 2, 9k squared minus 4k plus 1 equals 0. Again, one side is already equal to 0, so I don't have to move anything here. I can go right into identifying my A, my B, and my C. In this case, A equals 9, B equals -4, and C equals 1. Once I've identified them, then I can substitute them in. So I get D equals parenthesis -4 squared, because I want to make sure when I put square that -4 that I'm squaring the -4, not squaring the 4 and then taking it times the negative, minus 4 times 9 times 1. So once I've finished substituting in my values, I can do the math. -4 squared is 16. -4 times 9 is -36 times 1 is -36. So my discriminant equals 16 minus 36. So 16 minus 36 is -20. So my discriminant is -20. So how many and what type of solution do I have if my discriminant is less than 0? Two and I know the word roots is there. Usually we'll just say 2 imaginary solutions. And again, what this is telling me, if I have 2 imaginary solutions, this function does not cross the x-axis. And we will do more work later on. We'll come back and talk about what are we really saying when we're talking about an imaginary number, and what does that look like as a solution. We are going to stick with real solutions as far as all of our answers to quadratic and the other things, but we need to be aware that there is the idea of an imaginary solution out there, that's telling us that our function doesn't cross the x-axis. So the first two were already equal to 0, so we didn't have to do any additional work. Now we're looking at negative 7m squared plus 10m minus 2 equals negative 10. I do not have one side equal to 0, so I need to add 10 to both sides to fix that. So I have negative 7m squared plus 10m plus 8 equals 0. Now I can identify my A, my B, and my C. So in this case, A equals negative 7, B equals 10, C equals 8. Now that I have that set up, now I can substitute in. So D equals 10 squared minus 4 times negative 7 times 8. So D equals 100. What is negative 4 times negative 7 times 8? What does that come out to equal? Negative 4 times negative 7 times 8. What is it? 224. So 100 plus 224 means our discriminant is going to equal 324. So if our discriminant value is greater than 0, how many and what type of solutions do I have? Yeah, I have 2 real solutions. So again, what that is telling me is that my function crosses the x-axis twice. Number 4, negative x squared plus 5x minus 14 equals negative 5. Again, I need to add 5 to both sides. Negative x squared plus 5x minus 9 equals 0. So I need to make sure that one side is equal to 0 before I continue. Again, now I can identify A, B, and C. So in this case, A is negative 1, B is 5, and C is negative 9. And use those values to substitute in. So my discriminant equals 5 squared minus 4 times negative 1 times negative 9. So my discriminant equals 25. Negative 4 times negative 1 is positive 4. Positive 4 times negative 9 is negative 36. So 25 minus 36. So my discriminant equals negative 11. So if my discriminant is less than 0, how many and what type of solutions do I have? 2 imaginary solutions. In other words, this function is not going to cross the x-axis. And why that is helpful is that when we're doing the quadratic formula, we should know what our answer should look like. Am I only going to get one answer? Am I going to get two answers? We are not going to get imaginary solutions right now because we haven't really told you what that looks like, and we're going to get into it later. So it's okay with the discriminant to get a negative value, but I will tell you that is not going to happen right now with our quadratics. We're going to keep everything on the positive side, either equal to 0 or greater than 0 as far as our actual solutions right now. Which brings us to the quadratic formula. And you should notice that part of the quadratic formula there, what's under the square root, this right here is the discriminant. So what we were just doing there is part of the quadratic formula. But we were doing the math before you take the square root. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So again, the equation must be in standard form with one side equal to 0 before you substitute in any values for a, b, and c. So once again, we have to have ax squared plus bx plus c equals 0 before we can do anything. If one side is not equal to 0, then we can't work with that yet. We have to get it into that form to make sure we're using the correct values. So now let's go to the next page and look at some examples. Now, so you don't have to keep flipping back and forth, I'm going to write the quadratic formula here in the margin. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. That way you don't have to keep flipping back and forth. That is the formula we're going to be using. So number 5, m squared plus 9m minus 22 equals 0. One side is already equal to 0, so we don't have to move anything around. So we can go into identifying a, b, and c. In this case, a equals 1, b equals 9, and c equals negative 22. So now I can substitute in. So x equals negative 9, because it was negative b, so negative 9 plus or minus the square root of 9 squared minus 4 times 1 times negative 22, all divided by 2 times 1. So all I have done there is substitute in the values for a, b, and c. Bless you. So now as I start to simplify, x equals negative 9 plus or minus the square root. 9 squared is 81. Negative 4 times 1 is negative 4. Negative 4 times negative 22 would be plus 88, all divided by 2. So x equals negative 9 plus or minus the square root. What is 81 plus 88? 169 divided by 2. What is the square root of 169? Yeah, it's a perfect square. This number here is a perfect square. Now, they all won't be a perfect square, but just because it's one you may not recognize, make sure you check. So negative 9 plus or minus 13 divided by 2. Now, at this point, this is where we have to separate it out. We have that plus and minus. That plus and minus tells us one time we're going to solve it with plus 13, one time we're going to solve it with minus 13. So we're going to have x equals negative 9 plus 13 divided by 2, and x equals negative 9 minus 13 divided by 2. So what is negative 9 plus 13? 4, so 4 divided by 2 means that x equals 2. So one of the places where my function crosses the x-axis is at positive 2. What is negative 9 minus 13? So negative 22 divided by 2, x equals negative 11. So that is the other spot where my function crosses the x-axis. So my solution would be negative 2, or excuse me, positive 2, comma, negative 11. Now, could that one have been solved by factoring? Absolutely. That would be a choice if you were looking at it. That one, looking at the numbers, are small enough. I might try to solve that one by factoring. But again, the quadratic function works in any circumstance. So it's what I call it the fail-safe. You can't go wrong with the quadratic formula. It is going to work in every situation. Number 6, 3n squared plus 7n minus 76 equals 0. Even if this one factored, I'm looking at like the numbers negative 76. I would have to take that times 3, and then I'd have to find factors that add up to 7. Yeah, that seems like an awful lot of work when I can just go to the quadratic formula. Again, one side is already equal to 0, so I can go in and start identifying my A, my B, and my C. So A equals 3, B equals 7, C equals negative 76. So now I can substitute those values in. X equals negative 7 plus or minus the square root of 7 squared minus 4 times 3 times negative 76, all divided by 2 times 3. So x equals negative 7 plus or minus the square root. 7 squared is 49. What is negative 4 times 3 times negative 76? What is it? Before you, I just want those numbers before you add the 49. Should get 912. And then that's going to get divided by 6 because 2 times 3 equals 6. So x equals negative 7 plus or minus the square root. When you add the 49 and the 912, you get the 961 divided by 6. Is 961 a perfect square? If I put in the square root of 961 in my calculator, do I get a whole number? What do I get? 31. So x equals -7 plus or minus 31 divided by 6. So now I'm going to solve two equations. X equals -7 plus 31 divided by 6. X equals -7 minus 31 divided by 6. Again, that plus and minus is giving us our two equations. One time we're going to solve it with the plus. One time we're going to solve it with the minus. So -7 plus 31 equals what? So 24 divided by 6, x equals 4. So my function crosses the x-axis at +4. And then x equals, what is -7 minus 31? So -38 divided by 6. Does 38 divide by 6 evenly? So instead of turning it into a decimal or a mixed number, we leave it as a fraction, but we do have to reduce it. In this case, I can divide both of these by 2, which means x equals -19 over 3. And we're just going to leave our answer like that. And the reason I want you to get in the habit of that, again, as we're looking ahead to the final exam next week, which our final exam will be next Wednesday for second period, they would leave an answer like this as an improper fraction reduced down to its lowest terms. So I want to make sure that you do that. So my solution set here would be 4, -19 thirds. Number 7, 2x squared plus x minus 57 equals 9. Again, I'm going to add this just as a reminder. One side must be equal to 0. Just to remind you, we have to make sure we can't start anything until we have that situation. So in this case, I have to subtract 9 from both sides first. So I have 2x squared plus x minus 66 equals 0. I cannot start identifying A, B, and C until I make sure that that is correct. Now I can go in and take care of that. So in this case, A equals 2, B equals 1, and C equals -66. So x equals -1 plus or minus the square root of 1 squared minus 4 times 2 times -66, all divided by 2 times 2. So x equals -1 plus or minus the square root. 1 squared is 1. -4 times 2 is -8. -8 times -66 is positive 528. All divided by 4. So x equals -1 plus or minus the square root of 529 divided by 4. Now, it's not always going to happen. These set of examples, they all happen to come out as perfect squares. We will see some examples tomorrow where that's not the case. But here, this again is a perfect square. This is -1 plus or minus 23 divided by 4. So I have x equals negative 1 plus 23 divided by 4, and x equals negative 1 minus 23 divided by 4. So x equals negative 1 plus 23 is 22 divided by 4. 4 doesn't go into 22 evenly, but I can reduce them both by 2. So x equals 11 halves. And then x equals negative 24 divided by 4. So x equals negative 6. So one of my solutions is 11 halves and the other solution is negative 6. So again, so far the ones we've been dealing with, we get nice, pretty, perfect squares. We will look at examples tomorrow where that does not always happen.